In this lecture, we're going to look at an important topic, which is how to use data types to build various complicated programs. And so first we're going to talk a little bit about what I mean by a data type, what they are, and how you create variables that are of a custom data type. We'll look at what an application programming interface is, and we'll see some examples in the domain of image processing and in text processing. That'll be the bulk of the lecture, and we'll take a little diversion at the end just to talk a bit about different ways you can increment and decrement variables in a programming language. So this is a topic that sometimes confuses beginners, and it can also cause you some trouble if you don't know what's going on. And then finally we'll have a little practice looking at how methods are called and which method gets called and what's a valid way to call various using various parameters. When I talk about a data type, what do I mean? Well, it's a set of values and operations on those values. And we're not talking about just a simple primitive data type like an int. We're talking about some other custom data type, or maybe a data type that's built into the Java toolkit, and it represents a set of values, and these are things that variable or that object knows about itself. It may know several things. It may know, you could imagine a data type that knows its x and y location. Maybe it has some mass or some charge. It has a set of values that represent what that variable is about. It's persistent state. So as long as that variable is around, it maintains all those set of values and can use them. The other important part of a data type is the operations on those values. The object can define a variety of different things that could be done on the object. You could, for example, maybe draw the object or calculate its forces on another object or anything like that. And these are methods you will call. So things you'll call on the object that make it do various things or calculate various things. All right. Contrast this with primitive types. Primitive types are simply a name for a machine representation that stores a value, and they store just a single. They don't store a set of values. They store just an individual thing, like a true or false value, or an integer, or a floating point value, and it's at the level of sort of the machine hardware. And actually, the operations that they can do, you don't get to define these. There's only so many things you can do with an int, and you're not allowed to add anything to that. And actually these operations like add, subtract, multiply, and divide map directly to what the actual hardware, what those processors can do. They're useful, but they're not very flexible. They're kind of the basic things that can get a lot of jobs done, but they don't help if you've got very specific requirements of what you need your variables to do. Why do we look at sort of building a custom data type? Well, no one could really anticipate. The people that design Java or the people that designed any kind of programming language can't really anticipate all the potential types of variables that different people may need when they're using their programming language. You may need a variable to represent things in math, like complex numbers or vectors or matrices, polynomials. Or maybe you want to have a drawing program and have points and polygons, or maybe you're doing a physics simulation and you need to represent charged particles or celestial bodies that are orbiting around the sun, or whatnot. And Java, like many modern programming languages, allows you to define your own custom data types that can meet and fit the needs of your particular software application. And it's an important part of modern programming because it helps us manage big software. You're trying to build a really big product, and it may involve a whole team of programmers all working on different parts and trying to cooperate to achieve a common software end product. And this requires a lot of organization and structure, and data types can provide a way to manage that. You can break the complexity of that big software project into different components. Like, for example, if you're doing a physics simulation, maybe one person's responsible for coming up with a data type and testing the data type representing a charged particle, whereas somebody else is handling the celestial body object, and maybe somebody else is doing some of the math data types like matrices and vectors that are needed for the physics simulation and so on. And each person can kind of work a bit independently, and they can define simple and clean interface points where these bits of software fit together. And so if I'm developing this bit, all that internal junk, well, not junk, but that internal software, I can worry about that, and I only have to expose some simple interface points where the other guys, they just use those interface points, and they don't have to care about all this crazy complexity that I'm dealing with inside my software. So it helps us compartmentalize and manage large software projects. Once we start talking about data types, we also start talking about objects, and an object is just a variable that's of one of these data types. The object is the instantiation of a variable that's of some data type. And we might have, here are some example data types in the bottom, like you could imagine a color data type, and in fact there is. I'll show you in a bit. The Java toolkit has a built-in color object, and its set of values are 24 bits. It has 8 bits to represent red, 8 bits for green, and 8 bits for blue. Things you can do with the color object: you might be able to get the different color components, or change the color slightly, brighten it, darken it, and so on. Just like you might have a single color, so a color object could maybe represent a single pixel on your screen. A picture object represents all the pixels in an area. So you could have like a 640 by 480 grid of color values, and you might do stuff like set or get the color at a particular location, or do various things on the picture object. We've seen the string object before. The string object represents a sequence of characters, and common things you might want to do is see, well, how many characters in the string, get me a substring, compare this string with another string, make it uppercase, make it lowercase, things like that. When we start to do our own data types and using objects, we'll be doing what's called object-oriented programming. You create your own data types and then you use them in your program. And it's a popular paradigm in modern programming. So before you can use an object, you must create it. And this is where you need this new operator. If you've got a variable that's of some data type, say string data type, you must create it. And here's a two-step process. You wouldn't have to do it in 2 steps. You create a variable named s. It's of the data type string, and then we use the new operator to actually construct it. And constructors always use this new operator, and then they call a method, and the method name is the same as the data type. So you just take the data, whatever data type you're trying to create, you put it after the new operator. Then you have parentheses, and inside the parentheses are any parameters to the constructor. And the string constructor just takes a string, and that becomes the set of values. The set of values that a string knows are just that sequence of characters, hello world. And there may be different versions of this depending on the data type. Maybe we be able to construct it in one way or another way, and we'll look at that as we in future lectures when we start building some of our own data types. That is just the construction part. When you need to, so once you've constructed it, you've created the object and it has its set of values, and you want to now use those values or change the values or do something with it. And that's what I'm showing here. Whenever you want to use an object, you use the dot operator, and then you put the name of the method. In this case, we're calling variable s, which is of type string. And what we want to do, well, we want to call the substring method. So we do dot substring, and that substring method takes 2 parameters that specify what part of the string you want to return. And that's how you invoke an operation on a data type. Let's look at more at image processing now. Basic part of image processing is, well, images, they have pixels and pixels have colors. And what's a color? Well, a color is just a sensation your eye receives and decodes it, and you experience red or blue or whatnot. And in Java, in the color object that's provided in the Java toolkit, it's represented as an RGB triple, so a red, green, blue triple, where each component is a number between 0 and 255. You've got 256 possibilities for each of these three numbers, so you've got 2 to the 56 cubed total possible values. If you've got a 255 for the red, that means there's a lot of red, all right, the maximum amount of red. And if you have a 0, it means the minimum amount of that. Green is 0, blue is 0, so you would experience that as a red color on your screen. All right, if it's all green, it's green. All blue, it's blue. If all of them are maxed out, then it's white. If all of them are 0, it's black, and so on. The three colors, red, green, and blue, that triple of integer values is the set of values the data type knows. It's the persistent state. Whenever you create a color object, it's going to keep track of those three sets of, the three set of values. The color data type has an API, an application programming interface, and this is the public specification of what it can do. And here's a typical way we'll represent it. We'll give the name of the class, and its class name is color, but it's also fully specified here. It's in the java.awt part of the Java toolkit. And the color class has a bunch of methods you can call. First of all, you can construct it, and whenever you can construct it, you pass it the three integers, and that sets the initial color. Other things you can do, you can record, or you can ask to receive the, what value it has for red, green, and blue. You can ask it to convert itself to a brighter color and then return that new color. You can make it darker. You can return a string representation of the color, or you can test, is this color equal to some other color? Do I have the same red, green, and blue values? Now this is just a subset of the methods in the API for the color data type, and you could go to this URL or just Google for color class Java or something like that, and you can read all about the different methods. And the cool thing is, once you know an API, or once you know how to search for an API, you can see all the various things that can be done with that class, and then you can just use them. You don't necessarily have to look into the actual code, like how does brighter actually do its job. Well, I can just use that method and trust whoever built it did it properly. And that's kind of the beauty of object-oriented programming, is you can make and reuse a lot of existing code without actually having to understand all the twiddly bits that are inside of that particular data type. Let's build something somewhat interesting. Let's draw a random colored checkerboard. So we've done a checkerboard before, but I want to make like a random patchwork quilt of different colors. Users will say how big it is on the command line, so they'll pass in an integer. And the approach here is obviously, well, we've already got a red and black checkerboard program we've seen before. And here it is. We read in that integer from the command line. Then we set our standard draw X and Y scale to be, between 0 and that integer value. We loop over, the two coordinates, and we just basically alternate between black and red, and then draw filled squares that are offset so it's nice and centered, and then it draws our checkerboard pattern. All right. Oh, I don't want to show you the answer yet. So this is what we're going for. A quilt like that. Why don't we go ahead and let me pull this up in Eclipse, and here's the original version, and it's working on running. Oops. All right, it kind of hit itself. I don't know why it did that. All right, there you go. Here's I don't know, it's a 10 by 10 checkerboard, something like that. What we're going to do is change it. So instead of doing this, instead of just alternating black and red, we're just going to create a random color instead. So let's go ahead and we'll just get rid of that. All right, I want to create a new color object, C. All right, and so I've declared it. I've said I'm going to make a data type of type color. Its variable name is C. Use the new operator, and then always after new is the name of the class. And then what do I need to pass it? Well, I need to pass it a red, green, and blue value. All right, I haven't defined those yet. Okay, and so I'll do that beforehand. So I'm going to pass it 3 integers, and I want to just choose red, green, and blue values that are random. This will get me a number between 0 and 255. All right, being careful. All right, remember math.random is between 0 and 0.999999999. All right, I multiply by 256. That gives me a number between 0 and 255,999,999. All right, and then I cast it to an int. That gives me an integer between 0 and 255 inclusive of the 2 endpoints. Same thing for green and blue. All right, we construct the color. All right, and once I have that color, I can set the pen color and standard draw it to that color. Very good. All looks good except I've got this ugly underlined red. All right, and if I highlight it, it's complaining it can't resolve this color. It doesn't know anything about this color data type. Well, I said it was built in Java, but there are parts of Java that are really built in and parts that aren't so built in. And this is the part that you don't get by default. You must tell it you want to have access to this, and Eclipse can help you here. If I just click on that, you'll see what it's done is add this line to the top. So I could have typed that myself as well. This import statement just tells it, in this program, please allow me to use the color class. Right, now let's rerun it with that code, and we get a nice beautiful patchwork quilt. And we could crank it up if we wanted to. So let's go to, well, that was 20 by 20. Let's go to 40 by 40. And I don't know, should we go even further? Let's go to, I don't know, 200 by 200? No, I don't know if I should go that high. Let's see. Oh, very small. All right. And it's more like just a random array of pixel values at this point. And so I'm not going to wait for that to complete. That's a simple example of how we can use a different data type. Let me flip back to where I was. More image processing. Let's look at this class called Picture. Here's the public API for the Picture class. Picture can either create itself based on a file name, or it can create a blank picture of a certain width and height, so a certain number of pixels in the X and the Y direction. Operations on that picture. So what's the set of values a picture holds? Well, the set of values is a two-dimensional array of all these color values, right? If you wanted to represent our little green don't panic guy here, we would need a whole 2D array, and at each position in the array would be whatever color. So up here on the left it might be white, and then down here it might be greenish, and down here it might be red. That's the set of values that it knows about itself. Operations, it can find out, somebody can ask it how wide it is, how high it is, and the main ones we'll be using are getting a particular color value. So given a X and Y value, index position into the pixel grid, get me the color value, and given a coordinate, set the color value. And then finally, we'll also be calling the show. So the show will actually bring up a window so we can see whatever's in our picture object. Now, before we do something with the picture object, let's talk a little bit about colors. All right. our goal here is going to be to create a command line program that can, given a color photo, so given a JPEG or whatnot that's in color, convert it to grayscale and show it to the user. And all grayscale is one of these RGB triples where R and G and B are all the same value. In this case 105, this gives you this particular shade of gray. Alright, and obviously as the values get higher and higher, eventually as you get towards 255, 255, it will be completely white, and as you approach 0, it will be completely black. That's the first thing we need to know. Grayscale always has the same three values. Other thing we want to know is how do we convert? If we've got like a kind of a reddish purplish pixel, what should its grayscale color be? Well, there's a formula for it. Given our RGB triple, how do we convert it to a single number that represents the brightness? And here's a formula you can use, and I'm going to add these methods so I'm going to create a library. So in the past we've talked about static methods and libraries, and all I'm doing is creating a class called Luminous, and its job in life is to contain a bunch of static methods. It's a library of useful static methods associated with colors and luminance. And my method, all it does is somebody gives it a color object, it operates on that color object, so it goes dot and then the name of the method and gets the red, green, and blue, then runs it through the formula and returns that color value. What's a practical use of this luminance? Well, have you ever seen a PowerPoint where the presenter has chosen poor colors? I try not to do that, but even sometimes I fail. What I really should do is use this rule: is if we compare the luminance of two things and take the absolute value, to be visible and nice contrast, you're looking for a difference in luminance of at least 128, and the maximum you can get is white font on black, or vice versa. But as those colors get less white and less black, you get less of a difference in luminance. And this one's probably still okay. 105 is getting a little suspect, and as we get into this realm, these things get harder and harder for people to see. And here's a static method called compatible. This method takes two color objects. Alright, you pass in the color object A and the color object B, and then those two things are passed into our luminance helper method, and that computes that formula, and then we see what the math.absolute value, we take the absolute value of that difference, and this simply returns whether that's greater than or equal to 128. If you choose two good colors, then it returns true. If you choose colors that are too close in luminance space, then it returns false. How shall we convert a particular color to grayscale? Well, all we need to do is call our luminance function. That's going to return that double value that represents how how bright that particular color is. We're going to round it and then convert it to an integer, and that thing then will use that as the value for both the red, the green, and the blue component of our new color, and then we'll return that color from this method. Here's an example. If somebody gave you this blue color and the blue has a little bit of red, a moderate amount of green, and a lot of blue, you convert it to this version of the grayscale. And why is it 74? It's because we ran that RGB triple through the equation and got 74.445, which came out, rounded to nearest integer was all 74s. We now have all the building blocks in place for our grand grayscale filter program, and here it is. We're going to make use of the picture data type and the color data type, and we're going to use our library of methods, static methods in our luminance class. First line here is the one that's using the picture class. We create a picture variable called pict. It's of data type picture. It loads that picture from the command line. It now operates on that data type, obtaining the width and the height. It then has a nested loop, and it goes through all the pixel values. It scans across all the X and then goes down to the next and works its way all the way through. And at each particular pixel, it first pulls the picture out of the picture object by calling the get operator. It then uses the static method in the library luminance to convert it to a grayscale color, and then it sets that pixel. So it converts this pixel's color value to the grayscale value. And then once it's looped over and scanned over all these pixels in the 2D array, then it shows it. Alright, and I can show you this. We can run this on the command line. And so I've got a JPEG here called sunset. Maybe I guess you might want to, how can I open this easily? Can I just click on there? Nope, don't think so. Alright, let me surf to, hold on a sec. Alright, so that was a lot of effort to show you. Here's the color version. So this is the photo I took one year in the Canadian Rockies at sunset. Alright, very nice. Looks quite good. But now that I have my grayscale program, alright, I can run Java Grayscale and sunset JPEG, and there's the grayscale version. So arguably, I don't know, I kind of like it's, kind of more Ansel Adams-ish. I kind of like it. I think I kind of like it better in grayscale. Simple program, but I would point out, I mean, how far you've come from probably where we started in this course, when you are no longer just a slave to whatever program you can download from the internet. You can now, given the picture class, which is a class you can download from a Princeton site, and the color class that's built in, and a few little methods we wrote in Luminance, you can build your own program to convert. So you might imagine you have a bunch of photos in a directory and you want to convert them all to grayscale. You can now use this program you developed to do that, and you haven't had to do a lot of heavy lifting. You've just leveraged all the work of the people who built the picture class and who built the color class to do that job. And that's the power of learning the program, is now you can automate things that other people would have to do. Other people would have to load it up in Photoshop and then clickety click through the menus. You now know how to do it yourself, and you could imagine this is just one particular manipulation. You could mirror it, you could scale it, you could do all kinds of different operations pretty simply now that you have access to some classes and some data types that provide this functionality. Let's switch gears and talk about text processing. This is going to make heavy use of the string data type, which we've already seen quite a bit of, and the set of values of a string data type is a sequence of Unicode characters. And Unicode, just means it's not just A through Z. We can represent all kinds of different letters in different languages with accents and special characters and Chinese scripts and things like that. We'll just be working in simple letters and simple ASCII text, but in principle it could do all kinds of different languages. Here is the API for string, and again you can create a string by using the new operator and calling string and then passing it a string. String's a little special, right? Because you don't have to do it that way. You can just set a string equal to something. So if I just here's my checkerboard, and I can do this, okay, but if I wanted to do this, I could also do this. Alright, I could just assign it equal to. Alright, but normally when we have data type, okay, like color, to do something like color, we do need to do, use the new operator. Bunch of different methods. This is just a subset of those methods. Lots of useful stuff in the string class. So if you're going to do any kind of text processing, and it's a pretty common thing to want to be able to do, you should check out and see, before you develop your own method to do something, you should see maybe the good folks at Java Incorporated have come up with something you can already use. And again, like all these classes in the Java toolkit, you can go to the web and find out all the details about how exactly does index of work, and what do I pass in, and what does it return, and so on. All those details are just out there on the Java documentation out on the web. Here's some typical string processing code. Let's say we wanted to make a static method that tests whether a string is a palindrome, something that's spelled the same forward and backwards. We can pass in a string object and then call various operations, like how, we can see how many characters are in that, and then we can loop over half of them and compare the character in the beginning with the character at the end, and confirm that they are all, if we find any that don't match, well, then it's not a palindrome and we fail. We have to work our way all the way in from the outside comparing characters, and if we get all the way to the inside and nothing has mismatched, then we know we have a good palindrome. Second example is you pass in a file name, so you pass in something like mobi.txt, and you want to separate it out and have the mobi in one string variable and the txt in another. Here's how you could do it. You could call the index of operator, obtain the location of that, and then obtain a substring to the left of it and a substring to the right of it, and now you've separated that. In the top example, we're reading things in from standard input. Someone has specified a particular keyword they're looking for, and then we just read things in from standard input. We read in a single line of the string, and then we see, does that line we just read in, does it contain that target thing? And if so, we print out the line. Otherwise, we don't. And final example, let's read in things and only print them out if they're a hyperlink to an educational university. We can use the starts with. We can see, does this string S we just read in, does it start with this string, and does it also end with this string? And you could do this in a number of different ways, but by making use of these operators that are built into the string class, it's a lot simpler than going through that thing and comparing character by character. Does the first character equal H, and does the second character equal T? We can use these convenience methods and get our job done easier. Final example for text processing, and this is in the fields of genes and genomics, and we're going to represent these things. There's things called nucleotides, and they're just represented by letters A, C, T, and G. And the game we're playing is to look through this genome for a gene. And the rules of the game are a gene must have a start codon, and that's ATG. Then we're going to have multiples of 3 nucleotides, and they're sandwiched between a stop codon, for example TAG. And in the bottom example, we can see we've got our start ATG, we've got our end TAG, and between it we've got 3 multiples of 3, and this is actually the gene we're looking for. The game we're going to play is somebody gives us a really long string, and what we're going to do is identify all the blue sections, all the genes in that string sequence. Here is the algorithm we're going to undertake. We're going to scan left to right through this genome sequence, and that's in black here. We've got this big long thing, and we want to identify and print out any of those genes that obey the rules I just talked about. We're going to look for something that starts with our target codon, and when we see that start thing, we're going to set a variable we're going to call BEG. The variable BEG begin, we're going to set to the current index, and then we're going to look for that stop guy. And when we do that, once we find the stop guy, we're going to see, well, what's sandwiched between these guys? Is it a multiple 3? If it's a multiple of 3, then we're good and we can output the gene. We start at index 0, and you can see it's working its way from here. At first it finds, oh, I actually see tag. I see my stop codon is right there. Well, I haven't found, beginning is still -1. Alright, because that's what we started off before we start the algorithm. We can't have a stop before we have a start, so we just ignore that. We keep working our way down the string until we eventually get to, I0, 1, 2, 3, 4. At this point we realize, we found, at position 4, we found the start, ATG. We there carry on, alright, I keeps getting incremented, and eventually we reach I equals 9, and at that point we reach, there's a tag there, that's a stop codon. We can now see, well, let's pull the substring between, index position, 4 and this current position. What is, between there, and is it a multiple of 3? And it is, so we can go ahead and output that substring, and we found one gene. We reset this guy to -1, and then start looking for the next start guy, which occurs later in the string, and then we find the stop, and then we can output the short gene that only has one triplet. And here's the Java code that does that. We make use of these methods in string, so we call things in string like substring and equals. So we see codon is we're pulling out a particular substring, so we're pulling out a sequence of 3 and then seeing, does that sequence of 3 equal this target start, and if so, then we can set our begin variable. We can also see, well, does it equal the stop codon we're looking for, and if so, make sure what we have is a multiple of 3, and if so, pull that out, okay, and then print it out. It seems like, if you had to do this by hand, and this thing was really, really long, you wouldn't get this right. But a computer with a little bit of code, once you get this small amount of code right, then the computer can do this reliably day in and day out without making any mistakes. Alright, so that's it for data types. As a bit of a diversion, but something you may have run into already, if not, you're going to certainly see it in code, are different ways to increment and decrement variables. All the ways on the left end up with x being one more than it currently is. They're all just synonyms, more or less, for the same thing. If you put these on their own line by themselves, these 4 lines of code all do identical things. And the ones on the right are the same thing, but for decrementing. And why are there different forms? Well, one reason is these forms are just nice shorthand, right? X++ involves typing a little bit less than, x equals x plus 1. So they're shorthands, but what's with, what's the difference between x++ and plus x? All right. In this circumstance I'm showing here, it doesn't matter. And there's an excerpt from a book here, it does do the same thing, and it's claiming, except one is slightly more efficient than the other, and it's maybe more efficient from a typing standpoint, but it's not. That's kind of made me a little suspicious. I was like, well, is it really? I didn't really believe it was going to run any faster. I don't really believe any 4. Choose any one of these 4 and it's going to run just as fast as the other. Being a good computer scientist, I decided to verify this, and what I did is I created 2 programs. They do the same thing. All they do is increment a variable a trillion times. all right, or however many times I say on the command line. 1 does val equals val plus 1, and 1 does val plus plus. Is there any practical difference in these? And then here's some code that just times it. You can obtain a timestamp of the system when you start doing the increment, and then I obtain another one at the end. I subtract them, divide by 1,000, and print out the time in seconds. And the answer, yeah, it doesn't matter. Okay, a trillion, this was 592 seconds, this was 594 seconds. You know, you might think this one's more efficient. It's certainly shorter to type, but it's not clear, it's any faster or slower. So there's certainly no efficiency reason to use one or the other. But what is the difference between these two? What's the difference between the one on the left and the one on the right? The one on the left is called prefix, and the one on the right is called postfix. And in the prefix version, it's a difference of whether this thing is equal to the value before or after the change. All right. Important to understand, like if you use these on a line by themselves, like I've shown you in the blue boxes at the top, this distinction has no effect. Feel free to use whichever one you want as long as it's on a line all by itself and you're not assigning it equal. You don't have this expression on the right side of an equal. All right. After these lines of code execute, they both, this one's incremented by 1, this is decremented by 1, and x remains unchanged. All right, that's true of both the left side and the right side. Where you can get yourself into some trouble is code like this at the bottom. All right, we have a variable x. All right, it starts at 0 plus x. What this ends up doing is, all right, x is going to get incremented. All right, in both these cases, whether I'm doing the left or the right, x ends up getting incremented. The difference is, does z get assigned equal to x before it's incremented or after it's incremented? All right, and I can pull this up in Eclipse. This is showing the first two versions. Oh, and I got Hello World going on in there. I've actually got 3 versions here. Let's run it. I'll show you the output. These 3 programs, while looking quite similar, all end up with a different value of x and z. In the first case, this x value, this increment happens before the assignment into the variable z. Therefore, z ends up with 1, whereas this version, z gets assigned to the value of x before it's incremented, so z ends up being 0. All right, that's the difference. So if you're going to use it in this, you need to understand what's going on. So in general, I would avoid doing this. All right, there's no reason you need, there are occasionally reasons this is convenient, but in general, you have to know what you're doing, and if you forget, you'll have a bug, and you'll have to try and fix it. Be aware when you do something like this. So sometimes I see students and they misunderstand and think this results in x getting incremented by 1, and it doesn't. All right, all this does is puts the value of whatever x is plus 1 and puts that into z, but x is going to remain unchanged. X is still 0. All right, so the final thing we want to do today is a method puzzler. The game is to figure out, given the method on the left, it's a an operation on, you can imagine it's just a static method probably in a library. It takes a height and a width and calculates an area and returns an integer. The question is, which of the calls on the right are legal? Go ahead and pause the video and work out which of these 10 are valid and which are invalid, and why that's the case. Here's the first set I've eliminated. I've eliminated 3, 6, 7, and 9. And why are these invalid? Calc area takes 2 parameters, height and width. This only has 1 parameter, this has 0 parameters, this has 0 parameters, and this has 3 parameters. Java is not flexible in this regard. You must, if all you have is a calc area that takes 2 parameters, you need to send it 2 parameters. No fair sending it fewer or more parameters. Next ones we can eliminate. 5. Well, what's wrong with 5? 5 is got a variable t. It's of type long, and it's trying to pass that variable of type long as the first parameter calc area. And remember the rule, you can't fit, if Java will not let you put something that's bigger into something that's smaller, and a long is an integer that's really bigger than, can be much bigger than an integer, and it won't let you put, a big cup into something small like an integer cup. So some of the value might spill out. A similar problem is with 8. The parameters are okay in 8. 4 and 20 are both integers. It's trying to put the return result into a byte. And remember, a byte is like an integer, but it's really small. It can only be between, negative 128 and 120, positive 127 or something like that. It's much smaller. You can't put that integer into H without spilling, and Java will not let you do this, and it won't compile. Here we're trying to send 2 doubles into calc area, and it only takes integers. It will not automatically demote a double to an integer. 2.0, while 2.0, yeah, you and I know it's, that could easily just get converted to integer 2, but Java doesn't know that. And this, what if this is 2.1, and then what should it do? Should it round? Should it drop? What should it do? Java will not automatically demote doubles to integers, so that won't compile. All right, that leaves you with 1, 2, and 4 as the correct answer. Nothing wrong with 1. That's pretty much what you'd expect. Pass 2 integers, return an integer, all is good. Can you pass in a short instead of an int? Yeah, because a short is a smaller cup going into a bigger cup, integer cup, and there's no chance of spilling. And both of these 2 and 4, you might think, well, it's kind of, I'm not using the return result, and that's weird. And it is weird. There's no reason to call calc area if you're not storing the area calculation, but Java won't prevent you from doing that. All right. Maybe you're calling calc area to have some side effect inside. This method's doing something useful inside of it, and you don't really care about the return result. All right, you're not forced to use the return result, but it is weird usage not to. Here is another form of the same thing. What if we pass in 2 doubles and return a double? Which of these are legal? Pause the video and see if you can work out which of these are legal. What's wrong with 1? We're passing in, 7 and 12. That's not the problem. Integers will promote to doubles if necessary. The problem is with the return result. This calc area is supposed to return a double, and you're trying to put it in an integer, and that double return result will not demote to an integer, so that won't compile. Here we're passing in 2 doubles. There's no problem with that. But again, the double value can't demote to an integer, so the return result is what's causing the compile error. We're getting a good double return result here, but the problem with this one, we're sending in 2 strings, and Java is not going to automatically convert the 2 strings into doubles. If you want to do that, you need to do that by calling something like double.parseDouble. All the rest of them are okay. All these other types, double is pretty flexible. If you try and send it a short, an int, a float, all these types will automatically type promote to be a double if necessary, and there's no problem with that. Can we call it with 2 integers down here? Sure we can, and this returns a double. And can we put it into a string? Well, we can, but only because I've done this little trick. I put an empty string, quote, quote. This is of type string, And then because of that little trick, I can now append. Because this is a string on the left side, this plus is now string append and not normal mathematical addition. And it will just result in a string that contains the double value of calc area. To summarize, we talked about data types today. It's a set of values and operations on those values, and it's an important concept. You must create your objects using the new operator, and the whole basic idea is it allows us to build big complex software by just leveraging the work of other people, and also allows us to build complex software by isolating little bits into different compartments. We got a lot of practice today showing you how to use different data types, and we also had a little aside talking about the differences of how you can increment and decrement variables in Java.